Bismillahirrahmanirrahim. Assalamu alaikum, dear students. I hope that all of you are doing fine and staying safe. Previously, in our lectures, we have discussed about the networking. We have talked about different ways of wiring a network. Today, we are going to talk about different hardware that is required in making a local area network. And today, we are going to talk about another term called Ethernet. The LAN hardware have several terms. Few of those terms will be discussed in today's lecture. The first one is the server, repeater, bridge, network interface card, wireless access point or WAP, or wireless network interface card. So let's start exploring each of these devices in a bit detail, and then we will move on to the question answer session to have more clarity of our understanding. When we talk about the server, we actually are referring to a computer which is providing some sort of service to the other participants, other members of a network. We can call them nodes of the network. We also can call them the individual end systems which are actually getting service, some sort of service from the server. Imagine having a small network of 5 to 10 computers at your home or your office. You get a printer and you attach that printer to one of the computers over there. And all the other computers are sending print commands to that computer. So that computer has become your print server now, because all the network is getting the facility of printing from that one computer. In a local area network, in a LAN environment, you can also have another computer in which you can have the higher capacity storage devices. Excuse me. The higher capacity storage devices, and all the data and the files of different sorts can be stored on that one computer. And whenever any other computer needs some file, they can go to that computer and access the file from there. In that case, that particular computer will behave as a file server. You can also have a database server in your local area network. A server which is hosting one central database that all the other computers are using. In a broader sense, when we talk about a wide area network like internet as well, we have other types of servers as well. For example, we can have a web server. On a web server, our website is hosted. We can log on to that and see the web pages. We can have an FTP server on the internet as well. An FTP server, FTP stands for File Transfer Protocol. A server that lets you transfer, upload and download files from the internet. You can also have a proxy server to mask your locations on the internet. You can have a DNS server to look up the name of a website, the IP of a website, the name that you have just entered in the web browser. So in short, the server is a computer which is providing one specific or more than one services to the other computers on the network. That server can be a part of a local area, small network, or it can be on internet itself as well. Then we have a repeater. Remember that repeater can be used on a cabled network, on a wired network, and on wireless network as well. The purpose of the repeater is actually to keep the signal at its maximum strength. When the signal is traveling at a large distance, it starts to fade, it starts to lose its strength. And if there is no repeater along the way after a certain distance, the signal is going to just fade away. The signal is just going to be lost. So, in both wired and wireless communication, we install repeaters. The job of the repeater is to keep the signal at its strength. It can receive the signals, repeat them means make the signals at the peak of their strength, and then transmit the signal along the way. By using the repeater, we can transmit our signals over large distances without having the fear of signal having been lost. These two are the example of a cable based and a wireless based repeater. The idea behind both of them is still the same. They will get the incoming signals, repeat them, and means strengthen the signals, and then they will just give the output of the signals. Then we have network interface card. You have probably seen this on the back of your PC or maybe on the sides of your laptop. A jack like telephone cable, but a little bigger. We have already discussed that with the size of RJ45, and as you can see that this is a picture of a cable based network card, a wired network card. So in this particular network card, you have option of coaxial cable and the RJ45 twisted pair cable as well. The purpose of this card is actually enable a computer to have a wired connection and be part of the network. This network interface card contains the MAC address. You have studied MAC address in your O levels as well, the media access control, the physical identity of your machine on the network. This is the network card which actually has that physical identity. And in the list earlier, I discussed a wireless network interface card as well. So it actually does the same thing, but wirelessly. Using microwaves, it can send and receive signals and get your laptop connected to any network. Then you have a bridge. To understand the concept of the bridge, imagine two local area networks separately wired. You can imagine them as segments of one big network, but first you should imagine that there are two different local area networks. And for example, you have a local area network on the upper floor of your office, maybe six computers in that, and then you have another local area network in the floor above that has 10 computers, and you want to connect both of these network together. The device you are going to use for that is called a bridge. So a bridge is actually connecting two segments of a LAN, two local area network that are wired with the same technology. They can be joined together with the help of a bridge. This diagram might give you a better visual representation of that there are two networks, both from star topology, and a bridge is just a device joining their hubs. The bridge is a device that connects the same type of network. In star topology, we discussed that there is a central communication device to which all the computers are connected. In my first or second lecture of this lecture, we discussed about topologies, and we discussed about bus topology and ring topology and star topology and mesh topology. In particular, in star topology, we discussed that there is a central device and all the computers have their individual wired connection with that device. Now, that device can be a hub or a switch or a router. The difference between the working of all three, maybe it's the intelligence with which these devices operate. Remember, the hub was a device that had no sense of communication, no addressing. When a hub received data from one computer, it actually broadcasts the data to all the connected end systems. They all have to check whether that data is intended for them or not. Otherwise, they would leave it. If the data is intended for them, so they would pick it. But the hub is actually broadcasting. Even one computer is sending the data to the other computer. It's a one-on-one communication. Even then, the data is being broadcasted. Broadcast means it is being sent to all the nodes of the network. So that is actually causing a lot of unnecessary network traffic, and that is also causing the unnecessary processing power of all the computers to be consumed. A switch, however, is a little bit more intelligent device. A switch can keep track of the addresses, and the incoming transmission is sent only to the intended recipient as a unicast. Remember, the unicast was the type of message that is sent from one recipient, from one sender to one recipient. Switch can do that. Switch can remember the addresses and send the data only to the intended recipient. It doesn't work like the hub relaying the message to everyone on the network. A router is actually a better programmable form of a switch. From a router, you can limit the bandwidth of a computer, you can block user, you can uh, install firewalls on your router, you can have the network traffic screened and scrutinized. You can actually block certain connections, websites, web servers, services. So router actually gives you a complete control over your network, and it works like a small computer. Mostly the devices that you are using at your homes to access the internet are routers, different DSL routers. So one of these devices is at the heart of the star topology. Previously, in the early days of star topology, it was a hub 20, 30 years ago. Then it is replaced with the switch. Excuse me. And now we have the availability of routers as well. All of them have the similarity that they can work as a central connecting device in a star topology. This is just an attempt to show you the differences between the hub and switch and the router. These are the same things that we have just discussed. If you need to go through the slide, just pause the video and go through the slide. Then we have wireless access points or WAP. Now, wireless access point is actually something that gets the connectivity through a cabled, through a wired connection, and then it lets other devices to connect wirelessly to it. Imagine your home wireless internet modem. See that the landline actually connects to that, and through landline it connects to your internet service provider, but it lets other devices connect to the internet through the wireless. So a wireless access point, also we actually call it only the access point or AP, is a device which is connected with wire itself, but it lets other devices to connect to network wirelessly. It is not necessary that the wireless access point is always connected through a wire with its actual network, and other devices are connected wirelessly to the wireless access points. Sometimes, as we have seen earlier, repeaters can also function as the wireless access points. Then we are going to talk a little about Ethernet. Ethernet is a protocol that our computers actually use to connect with each other in a local area network. Whenever I use the word protocol, you should understand that it's a set of rules to accomplish a particular task. So Ethernet is actually a set of rules, a protocol to let the local area network computers communicate with one another. Ethernet was in the beginning developed independently, but then it was taken over by the IEEE, Institute of Electrical and Electronics Engineers, and its subcommittee 802 actually took over Ethernet protocol for standardization. Later on, the different variants, different versions of the Ethernet protocol emerged. The wired protocol is 802.3, and if you ever have checked the back of your Wi-Fi router, the wireless protocol is 802.11. So 802 is the subcommittee number of IEEEs, which is actually responsible for standardization of the Ethernet, and it has then different variants, some of this protocol dealing with the different areas of connectivity. A network can be made using the wires, that is Ethernet protocol. A network can be made using Wi-Fi or Bluetooth or WiMAX. So all of them have different variants of this same Ethernet protocol to provide the connectivity. Ethernet actually exists in the uh, physical layer of OSI model. It has actually evolved from standard to 100 gigabits. Just to give you a point of reference, the fast internet, the fast Ethernet was able to give the bandwidth of 100 megabits per second in the network. The gigabit actually means that it was able to deliver 1 gigabit bandwidth inside the network, and 10 gigabit and 100 gigabit variants generations are actually capable of delivering that much data traffic within the network. So different generations of Ethernet actually depicts different generations. To visualize the Ethernet, I will have to refer back to my lectures of networking topologies. Initially, only bus topology or star topology were used in that. Remember, the bus topology was actually a single line, a single wire, and all the computers were connected on that same wire. And in star topology, there was a hub in the center, and all the computers are connected to that central hub. In the Ethernet, message was broadcasted to all. There was no way that you can actually send the message as a unicast, as a one-on-one transmission. And once the message has been broadcasted, all the nodes of the network would check if they are the intended recipient, if that message is for them. If yes, they would pick up the message. If not, they would neglect the message. Then there was one more protocol in place that is called carrier sense multiple access with collision detection, or in short, it was called CSMACD. Before telling you about this protocol, visualize the network of a bus topology again. When a computer has to send data, it has to use the common channel, which is the bus. And if some other computer has to send data, it also has to go through that same channel. So if more than one computers try to send the data at the same time, then the collision would occur. And CSMA-CD was the protocol to deal with that collision. What happens was a computer would check the voltage on the transmission medium. If the voltage was high, that means the data transfer is being done. If the voltage is low, that means the transmission medium is free. If the transmission medium is busy, the computer would wait for a random amount of time and then check again. If the transmission medium was free, the computer would start sending the data and then it would continuously check for a collision. If somebody else would try to send the data, a collision would occur. If nobody is trying to send the data, only a single computer is sending the data, there is no collision. The transmission will continue. But if a collision is detected, the transmission will stop and a jamming message will be sent to all the end system to alert them. And after a random amount of time, the computer will try to send the data again. So this protocol was actually a fail-safe to avoid the collisions when the different computers trying to broadcast the data on a single shared medium. This was actually the fail-safe to prevent the collisions from happening, prevent the data from being lost. I should mention that this is actually a legacy protocol now because then we have adopted the switches, and as I told you, switch actually operates on full duplex individual connection, and it is sending the messages to only the intended recipients. It is not broadcasting, it is unicasting. And since all the computers have their own full duplex connections with the switch, the collision cannot occur. But it is a legacy protocol, it is still part of the Ethernet package. We'll now going to move to our question answer session. If you have any question about that, now is the time. See you again on Thursday with the next lecture. Allah.